So today we are going to start with a new topic, that is the D and F block. So before we proceed, I would like to just share a few the past knowledge related to this. As you all know that we have many elements which are occurring in nature, right? So we cannot, like if we want to study, if we wish to study about each element, so it is very difficult. We cannot do that. So that is why the classification is important. And how the elements have been classified, there were different attempts made by different scientists and you know that all of those scientists just made a certain attempt that to classify according to increasing atomic mass, do it according to increasing atomic numbers. So blah blah, we have lot of you can say that lot of thoughts which the scientists just use to classify the elements. So on the on arriving to conclusion, what is that, like in today's era what we have the classification of the elements in a tabular form, that is in a group and period in a modern periodic table. So when we talk about modern periodic table, so you know that the modern periodic table is divided into 4 blocks. That is the S block, P block, D block and F block. And now you must be thinking that what actually suggests the element to be a member of S block or a P or a D or an F block. So it merely depends upon that to which the last electron enters. Like if the last electron enters the S orbital, but definitely it belongs to a S block. And if the last electron enters to the P block, it is a member of P block. And if the last electron, valence electron enters the D orbital, then definitely it is going to be a member of D block. And if the last electron enters into the F orbital, so it is a member of F block, right. So just depending upon that to which orbital the last electron enters, or to which orbital the valence electron is present, so that is actually the main thing which is responsible for the element to be a part of S block, P block, D block or F block. So now today we are going to start with the D and F block. As you all know, I told you just that obviously if we are talking about D block, so that means the electron enters, the last electron, the valence shell electron enters to the D orbital. That is why it is a member of D block. And the elements which belong to F block, now obviously their last electron is entering into the orbital, that is the F block, F orbital. That is why they are a member of F block. So you know that we have the specific names also, like the D orbitals, the D orbital elements, they are actually called as transition elements. They are called as transition elements. The reason behind this name is that because here we have metals, typical metals, and here we have typical non-metals. So when we are moving from metals to non-metals, so the metallic character is somewhat decreasing and non-metallic character is increasing. So we can say that there exists a transition. That means these elements are showing properties which are related to the metals also, and few of them are related to the non-metals also. So that is why the elements which are present in this block, they are called as transition elements or metalloids, because they have some properties similar to metals and some properties similar to non-metals. So this is what is the transition elements they are called as. And this F block, actually they are called as inner transition. They are called as inner transition elements. Now the reason behind the F block to be called as inner transition elements, because here you can see these F block is actually present in this transition element group, in this block. See here the inner transition element starts from this lanthanum, the first series, and the other one starts with this thing, actinium, this series. So that means these elements actually belong to this place, but actually they are squeezed up and they are placed at the bottom of this thing, the D block, into separate periods. So that is that is why their name is inner transition elements. That means inner to the transition elements, because they are present along with the transition element, but still they are squeezed and they are actually they are indicated by one place, and they are squeezed and they are just placed separately in different periods, this thing below the D block. So this is what is the D and F block, and I think it's clear that what is the D block, what is the name, why they are called as transition elements, why they are called as inner transition elements, and how they are placed. It is clear. So now we are just going to concentrate first on the D block. So the D block elements are those actually which have incompletely filled d orbital, which have incompletely filled d orbital. Like I have scandium here, atomic number 21. So I can just show you with an example. So if I write its configuration, it is going to be 1s2, 2s2, 2p6, 10, 11, 12, 18, 19, 20 and 21. So as you can see that they have incompletely filled d orbital, so that is why it is a member of d block. It is a member of d block. So we can say the d block elements are those which have incompletely filled d orbital. So how many periods actually consist of d block elements? So it actually starts from the third group and extend up to 12th group. That means these are the 10 rows. The 10 rows are of transition elements. And how many periods? It is starting from the 4th period. So 4th period is of transition elements, 5th period, 6th period and 7th period. So that means from group 3 to group 12, starting from 4th period to 7th period, all are transition elements, that is they are metalloids, right. So in the first period what we see, the filling of 3d orbital take place. In the first series, the filling of 3d orbital, as I took an example of scandium, you can see that here for scandium, which is the first element of the 4th period, you can say the transition element, it's this thing, its configuration is 4s2 3d1. Here will be 4s2 3d2, 3d3, 3d4 and at the last we will see that it will be 3d10. So that means in this the filling of 3d orbital occurs from 1 to 10. Second, in the 5th period what we see here, the filling of 4d orbital take place, starting from this thing 4d1, that is the 5s2 4d1 and extending up to 5s2 4d10. Similarly, in this case, we have 6th period where the filling of 5d electrons will take place, starting from 5d1 and ending up to 5d10. Likewise, here the filling of 6d orbitals will take place, starting from the 6d1 and extending up to 6d10. So that means I think it's clear that in the first period we are filling 3d orbitals, in the second we are filling 4d orbitals, in the third we are filling 5d and in the fourth we are filling obviously the 6d orbitals. As we know that d orbital can accommodate maximum of 10 electrons, you know that. The d orbital can accommodate maximum of 10 electrons, right. So that is why we see that 10 elements are there in each period. There are 10 elements in each period. Now, talking of this thing, we have certain exceptions also, as it is a difficult task to arrange so many elements in a tabular form considering only one property. So if we consider one property and we just think that the similar elements can occur together, so it actually happens in a periodic table, but still we get to see many exceptions. Still we get to see many exceptions because all the properties cannot be fulfilled by the all elements. There must be certain exception, but still we have to stick to a certain property while arranging the elements, because then only we will be able to arrange them, otherwise everything will be just shuffle out and the classification won't be possible. So when the modern periodic table was made, so there were few elements which were you can say which were showing an exceptional behavior. So likewise in this case we have zinc, cadmium, mercury being a part of transition elements. So as I told you that the transition elements, that is the d block elements, are strictly those elements which have incompletely filled d orbital. That means they should have 1 to 9 electrons in them. But if they are having d as 10, so obviously they are not a part of this thing, the d orbital. But still we get to see that few elements are placed in this block as they are having, though they have the completely filled d orbital, but still they are regarded as d block elements, or you can say they are not regarded actually, they are showing properties similar to the d block elements. And what are those elements? This zinc, cadmium and mercury. So let's see that how they are not this thing, what is an exceptional behavior they are showing actually. So I have the configuration for you. This is zinc atomic number 30. You know how to write the configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So that means here the last 3d orbital is completely filled. That means it possesses the 10 electrons. Similarly, when we see for cadmium, it is 5s2 4d10, again the 4d orbital, because it is a member of second period, so that means the 4d orbital is completely filled. If we talk of mercury, whose atomic number is 80, so we see that at the end there is a filling of 6s and 5d, and we get to see that 5d is completely filled. That means it possesses the 10 electrons. But as suggested by the definition, it was clear that the orbital which will have incompletely filled d orbital will be a d block element. But here we get to see that the block is actually, the orbital, that is the d orbital, has completely filled, because it has the 5 orbitals, so it can maximum accommodate up to 10 electrons. So they don't have any incompletely filled orbital actually, they have all the d orbitals completely filled. But still they are placed in the d block as they actually, their properties actually match with these metalloids. So this is an exceptional behavior, right? So I think it's clear that though they have the d orbital completely filled, but still they are placed. The reason behind is that because their properties are actually similar to the d block elements, right? So this is the zinc, cadmium, mercury, you need to remember that. And also we see that in this block we have the coinage metals also. That is the copper, silver and gold, right? So we have the coinage metals. That is also an exceptional, you can say, the classification, because we have placed the coinage metals along with the metalloids. So this is what is the D block. Now coming on to F block, as I told you that the one more thing, like when we were doing the D block, you have to actually remember the from what atomic number to what atomic number the periods actually extend. So in the first period, we know that the filling of 3 orbital will take place. It will extend from 21 to 30 atomic number, right? You need to remember that. In the second period, it extends from 39 to 48, 10 elements. Obviously, in all period there will be only 10 elements, because the orbital can accommodate maximum of 10 electrons. The reason is that. In the third period, what we have 57 to 80. We have 57 to 80. So that means 57 to 67, 10, 67 to 77 again 10, 20, and 77 to this 80, that means 3. So that means it has got 23 elements. So don't think like that, the third, sixth period and seventh period is violating the rule. It is not actually violating the rule. It possesses 10 elements only. But here what we do is from 57 to 71, the elements are actually squeezed up at the one place here, and starting from this number, like after that, that is from 58, we have this F block series placed at the bottom. So that is why it will consist only of 10 elements. But if somebody asks you that how many elements are actually present in the sixth period, you are going to say that actually it has the elements ranging from the atomic number 57 to 80, but the 57 to 71 is actually 58 to 71 is just squeezed up, and they are placed below the D block in a separate series. So this is what you need to remember, because they are inner transition elements. Their place is indicated in the D block, but actually they are not placed, because if they would have placed here, they would have just destroyed the shape of the periodic table. Right, so now it has a particular kind of shape and we need to maintain that. So that is why for the proper understanding they are placed below. Right. Similarly, it happens in the seventh period. From actinium, that is from 89, it ranges from 89 to 112. But from 89 to 90 onward actually, 89 is placed here. After that, that is from 90 to 103, it is being placed in the separate series. They are regarded as inner transition elements. So I think it's clear that what is the basic introduction for the D block. Now coming to the F block. F block elements are those which have incompletely filled F orbital, and you know that range that starts from is this place is indicated by lanthanum, and from lanthanum it is cerium, that is 58, and it extends up to lutetium, that is the 71. And this first series which is actually after the lanthanum, so that is why it is named after the lanthanum as lanthanoids. And this one is actinium, and after the actinium we have thorium extending from 90 atomic number to 103, that is lawrencium, and as they are placed after actinide, so that is why they are named as actinoids. So these are the F block elements, that is the inner transition elements, as I told you, because they are present inner to the transition elements, right? Their place is actually here, but they are squeezed up and they are kept separately. So this is what is the the D and F block. Now the reason behind that, why we are studying this D and F block, because you must be thinking, because we have so many elements and why we are studying about those elements, there have to be certain purpose for that, right? So the reason behind the study of D and F block is that because they are widely used in many fields. They are actually widely used in many fields. So just have a glance on that. So you know that all the developments that take place in modern life, that is the bridges, the you can say the pillars and all, they all make use of iron, you know that. And you know that iron is actually the member of this D block, right? So that means its elements are playing an important role. One more, you know alloys, you know that very well know that what are alloys actually. It is homogeneous mixture of two or more metals. So alloys like brass, bronze, the amalgams, you know that all of them actually belong to the D block. And likewise we have the catalyst. What is catalyst actually? It is a substance which affect the rate of reaction without undergoing any change in itself. And there are certain processes where the catalyst is badly needed. Like for example, in the synthesis of ammonia, that is the Haber's process, there we need a catalyst iron. If the iron is not present actually, so there won't be any the reaction won't be happen in that case. And moreover, like if we want a catalyst to function in a proper manner, we have a catalytic promoters also. Like in Haber's process, it is molybdenum oxide. So you know that molybdenum is also a part of d orbital, and even the iron is a part of this. So that means, and all one more thing, the reducing agents which we commonly use, that is nickel, platinum, palladium, they are all parts of D block elements. So that means again they are playing an important role in the chemistry, because they are they are being used in the various processes which leads to development of many other substances also. And you know the batteries which we use actually, the batteries, the automobiles won't have been running on the roads without the batteries, you know that. And it make use of zinc, nickel, cadmium. They are again the members of D block elements. So as a whole, we can say that D block and F block elements are playing an important role, particularly if we talk about the D block ones. They are playing an important role as they have been widely used in many things, many things. Even in medicinal industry we have a certain use. So that means because they are solving many kind of purposes, they have a constructive use actually. So that is why there is an urgent need that we should be familiar with actually the D and F block elements, that what properties actually they possess and what properties actually make them so special, that we have a separate chapter in which we are doing about D and F block. So this is the basic introduction about D and F block. So now we are starting with the properties, starting from the electronic configuration, and we will extend up to physical properties and extend up to chemical properties, so that you should be aware actually that what special things they actually possess, right? So just look at the board.